Okay, hi everyone, welcome back to this video series on Introduction to Firewalls, Designing Advanced Protocol Rules. This chapter looks at common applications, services, and connectivity solutions that are used on the internet and their related protocols. In most cases, more than one firewall rule is required to enable these applications to be used through a firewall. More specifically, we cover the required rules and design issues to consider when implementing the following mail services. Internet email requires rules for both sending and receiving email to ensure that only authorized packets can reach the email server. Authentication services. Authentication is used to identify specific users when they connect to resources hosted on your network from the internet. A user is authenticated against an account database. The section knock knock who goes there located later in this chapter looks at the most common authentication protocols used on the internet today. Internet protocol security, IPSec encryption. Not all protocols can take advantage of application layer security. For example, although a web server is able to use secure sockets layer SSL to protect hypertext transfer protocol HTTP, another application may not know how to use SSL. In these cases, IPSec can be implemented to encrypt and decrypt data at the IP layer without the application being aware of the encryption process. Tunneling solutions. With the advent of broadband technologies and work-at-home policies, more employees are connecting to corporate networks by using tunneling solutions that send traffic in encrypted form across the internet between the employee's computer and the corporate network. Depending on the tunnel solution implemented, different rules must be applied at the firewall. Getting an email through. Most of us can't live without email services. Internet email allows us to communicate with friends, colleagues, and business associates to exchange information. When a firewall is placed between you and the internet, the firewall must be open to allow email to pass both to and from you. Before you go any further, look at the protocols related to email services. Post Office Protocol version 3. POP3 is the most common version of email access protocol used today. POP3 is used to retrieve email messages from a mail server. The most common misconception is that POP3 is also used to send email. You can only retrieve email by using POP3. By default, connections to the mail server using POP3 connect to TCP port 110. In many ways, the process is the same thing you do every day when you check your mailbox for new mail. You know, snail mail. You don't camp out at the mailbox, but go at regular intervals to see if you received any new mail. Internet Email Access Protocol version 4. IMAP 4 is a newer protocol that provides access to a user's mailbox on a mail server. The advantage of IMAP 4 over POP3 is that more folders are available to the user than just the inbox. By using IMAP 4, a user can access all email-related folders on the mail server, such as the outbox and sent items and deleted items folder. In addition, if the email server supports public folders, IMAP 4 also provides access to these folders. By default, connections to an email server using IMAP 4 connect to TCP port 143, Simple Mail Transfer Protocol. SMT provides outbound mail transport. Anytime that you send an email message to another internet email user, SMTP is used to send the message to your mail server. Then your mail server transports the message to the target mail server again by using SMTP. By default, connections to the mail server using SMTP connected TCP port 25. You have no control over the actual routing used by the mail server to send the email message. This is similar to what happens when you drop a letter off at the mailbox. All you know is the letter will end up at the recipient's mailbox. Lightweight Directory Access Protocol, LDAP. Have you ever tried to find a person's email address by sending a query to a mail server or directory server that uses LDAP? You can determine the email alias for your intended recipient. By default, connections to a server using LDAP connect to TCP port 389, answering the right questions. Before you configure a firewall to support mail services, you must first determine exactly what type of email-related network traffic will be allowed to pass through the firewall. To profile the allowed traffic, start by answering the following questions. Does your company need to accept email messages from the internet? If your company receives email from the internet, you have to allow incoming email to pass through your firewall. Allow incoming email requires that your email server be protected so that it doesn't end up acting as a relay host for spam. What mail clients are supported when accessing mail services for your company? Not every email client supports the same features. Identifying which email clients are supported assists you in providing the maximum level of security without blocking access to email resources. Will external email clients connect from behind your company's firewalls? Not every organization allows access to external mail services. If the other company doesn't allow your clients to connect to your mail services through its firewall using mail protocols, sometimes solutions can be developed that make use of protocols commonly allowed through another company's firewall, such as HTTP or HTTPS. Allowing access to external mail services. Table 8.1 shows the firewall rules that are required to provide external mail access. Table 8.1 shows the firewall rules that are required to provide external mail service access to computers on your internal network, IP subnet 172.168.1.0/24. These rules allow users behind your firewall to connect to other mail services on the internet. So you can see here, so POP TCP 172.16.1.0/24, any 110 allow POP 3, STCP 172.161.0/24, any 995 allow IMAP TCP 172.161.0/24, any 143 allow IMAP STCP 172.16.1.0/24, any 993 allow SMTP TCP 172.16.1.0/24, any 25 allow SMTPS TCP 172.161.0/24, any 465 allow HTTP TCP 172.161.0/24, any 80 allow HTTPS TCP 172.161.0/24, any 443 allow LDAP TCP 172.161.0/24, any 389 allow LDAP STCP 172.161.0/24, any 636 allow. Allowing access to internal mail services. Table 8.2 shows the firewall rules that are required to allow external clients to use internal mail services. In this example, the mail server IP address 172.161.1.21 0 is located behind a firewall that performs a static mapping from the externally advertised address to 172.16.1.210. So POP3 TCP ANI 172.161.210.110 allow. POP3 S TCP ANI 172.161.210.995 allow. IMAP TCP ANI 172.161.210.143 allow. IMAP STCP ANI 172.16.1.210.993 allow. SMTP TCP ANI 172.161.210.25 allow. SMTP TCP ANI 172.161.210.465 allow. LDAP TCP ANI 161.210.389 allow. LDAP TCP ANI 161.210.636 allow. HTTP TCP ANI 172.161.210.80 allow. HTTPS TCP ANI 172.161.210.443 allow. To allow remote connectivity to an organization's network, remote users must authenticate with the organization's directory service. The most common method used to provide remote authentication to a network is remote authentication dial-in user service, Radius authentication. Radius provides the ability to authenticate dial-in virtual private network VPN and wireless network connection attempts. In all of these cases, Radius allows centralized authentication for the network, removing the need for separate directories for each remote connectivity service. Many remote access servers and wireless access points can be configured to forward authentication requests to a Radius server rather than having to perform the dial-in authentication themselves. Figure 8.1 gives you an idea of how such a forwarded authentication takes place. In this figure, the remote access client can dial into any one of 3 dial-in servers: 23.222.15.8, 23.100.24.5, or 23.10.10.10, and use the same credentials. These credentials can be used even if the 3 dial-in servers are owned and operated by different internet service providers, ISP. Each dial-in server must be configured as a Radius client to the Radius server located at IP address 39.200.1.2. Radius functionality. Radius is used to provide the following functionality to dial-in network solutions: centralized authentication. All authentication requests are passed to a single account database for an organization, which eliminates account and password synchronization issues. Centralized accounting. Dial-in servers that are configured as Radius clients can be configured to forward all logging and accounting information to a Radius server. This forwarding ensures that logging takes place at a centralized location. Centralized security settings. Radius servers distribute centralized security settings to configured Radius clients by implementing remote access policies. This centralized distribution of the remote access policies ensures that consistent security is applied at all dial-in in servers, thus eliminating security breaches due to non-standard security settings. Configuring inbound radius firewall rules. If you use radius authentication or accounting, your firewall must be configured to allow radius packets to be passed to the radius server behind your firewall. As shown in figure 8.1, only 3 dial-in servers are configured as radius clients. To restrict radius access to only those 3 dial-in servers, the rules in table A3 can be configured at your firewall. So radius authentication UDP 23.222.15.8 ANI 172.161.212.1812 allow radius accounting UDP 23.222.15.8 ANI 172.161.212.1813 allow radius authentication UDP 23.100.24.5 ANI 172.161.212.1812 allow radius accounting UDP 23.100.24.5 ANI 172.161.212.1813 allow radius authentication UDP 2310.10.10 ANI 172.161.212.1812 allow radius accounting UDP 2310.10.10 ANI 172.16.1.212.1813 allow. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.